Welcome to Luca is a Billionaire, where the only thing I invest in is your answers.
You start by verifying hardware choices and getting hands-on immediately. Connect the microphone to the Pi or Arduino and wire ground/common first to avoid spikes. Once done, attach motor driver VIN to the 5V supply, then connect the controller TX/RX for serial commands. This prevents signal collisions. Make sure to enable SSH or serial console so you can push audio code. You are doing this now because correct initial wiring avoids reboot loops and fried components later. Now install the speech stack and connect it to your control loop. You install Vosk for offline recognition, then create an intent parser that maps phrases to actions. This reduces false triggers. Once the parser is stable, feed intents into a finite state machine that emits velocity setpoints. Next, integrate a PID controller on the motor outputs so voice commands translate into smooth movement. Finally, add emergency stop logic that overrides the FSM when safety thresholds are exceeded. Finish by running full system trials and validating timing and reliability. You run scripted phrases and measure latencies between audio input and motor response. Log events with timestamps to find bottlenecks. Once done, tune voice confidence thresholds and PID gains to balance responsiveness versus stability. If commands misfire, isolate audio paths and replay recorded samples. A key troubleshooting step is to swap the microphone or raise input gain. This often reveals whether recognition errors are acoustic or software related.
Thanks for watching and please subscribe. It's the best investment you'll ever make.